So good morning everyone. We are gearing up to get started for today. Today will be the first of our machine learning classes. I'm sure we are all excited and looking forward to having an exciting time. So my colleague will be taking us on the class session today, but just before we get started, as always, please let's begin to sign in the attendance. You can scan the QR code or just use the link there to sign in. So people on YouTube, Zoom, we can all begin to dial in. Good morning, Zion. Glad to have everyone on call today. All right, so just give 5 minutes before we start for everyone to join in, and I'll introduce our tutor for today. All right. So welcome everyone once again. Good morning, Richard. Good morning. Okay, sorry, I just realized. Okay, so all I was saying is that the link is on the info pack for this session. So as always, you can always find all the details there. My colleagues also will drop the link on the chat, but you can simply just go to the info pack and get all the details that you need. Quiz for the last session and the other details will be updated today, right? So let's make sure that we check that after the class. Okay, so since we are starting the machine learning stream again today, I'll just quickly go over the requirements for certification so that everybody's on the same page as we proceed. And it's just as we said, at least 8 of the 12 daily quizzes must be completed. Your scores are not what's important, it's the fact that you are able to complete the daily quiz. Also, attendance. Attendance must be completed between 10 a.m. and 12 noon, and you must attend 6 of 12 classes, that is 50%, right? Also, you must complete the cargo competition, which will be covered later in this class, how you will register on cargo, do the hackathon, do your skills test, build your data models, and all that. So, as always, let's pay attention, ask your questions if you have, and if you need other details, they will all be shared with you in due time. Okay, so welcome once again, and let's get started for today. I'm really excited because starting off the machine learning stream today, we have my amazing colleague, Bimileke, who is going to be taking us on machine learning. So he'll come up, he'll introduce himself and start us off. All right. Okay. All right. Cool. Okay, so have a wonderful time. And remember, if you have any questions, just ask on the chat or on the channels after the class. So over to you, Leke.
Hello everyone, good morning or good afternoon for those, good afternoon, good evening from those who have been joining us maybe later watching the YouTube videos. But for those people in the office, good morning. So my name is Demileke Odedide. I do machine learning and data science in Nigeria. I also do a lot of other stuff. So I also do a lot of other stuff also. I do research. I work in the edtech space also. So I'm a coat of many colors in a sense. You don't know to think that way. So before we start, so today we'll be talking about machine learning. Really a brief introduction of machine learning. But before we start, that's a bit better. Maybe you can. So before we start, we just do a brief introduction of what we learned. What's it called? On Python, about Python. Okay. People online, can you hear me? If you can't, please just drop the chat. So that's now that. Oh, my next was fine. So if you can hear me, just okay. Okay, thank you. Thank you. Okay. I would. Okay, so I'm trying to open the tablet now. Where we can just do a basic.
Hello.
Okay, so just give me a moment. I want to open a new notebook, and then maybe we can do okay, yeah. So this video. Okay, so just a basic introduction of what we've done in Python. So can someone just list or just mention some of the kind of data structures, the kind of data structures we have in Python? And when I'm talking about data structures, I'm talking about the variable types that we have in Python. So both people online and in the class, especially people in the class. So can we start from people in the class, please? Yeah, yeah, yeah. Okay. So someone mentioned we have list, string, tuple, and dictionary, right? Can someone tell me the difference between tuple and a list? Tuple and a list. List are mutables. Tuple are okay. Someone said a list is mutable. No, no. A list is mutable, tuple is immutable. What do you mean by mutable for in case for those people that are not as tech savvy as us? So what do you mean by mutable? Okay, so you can add value to or delete. Okay, but for tuple, can you add? You can add. You can delete them. Okay. What about dictionary? Can someone tell me the main advantage of the dictionary? Okay. There is a reason why it has a key value pair. It does. Okay, out of all the data type, it's the only one that has a key value pair. So that's unique. But there is something unique why people use it. Huh? Okay, sorry, let me check. I should also be checking the chat also. Okay, so can someone tell me something also that's unique about dictionary? Very unique. Okay. Okay. So in dictionary, there's something we call hashing. They will tell you the dictionary is hashing. And to look anything up in a dictionary will take you a constant time. This may not be uh, this may not be within your scope because you are just starting, but it's important to notice. To check, okay, let's say for example, I create my list. I create my list and then I put variables inside it. I put okay, let's say we put a day by your bio Tolu, and then uh, let's say BC. So I think it's balanced like this. Two boys, two girls. Sorry. Okay, someone is saying the screen is not showing. Fumi, please, can you confirm if my screen is showing over there? Okay. I think I'm typing inside the other window. Please confirm if you can see my screen now. Okay, can someone? Okay, yes. Okay. Okay, okay. So thank you, everyone. Okay. So sorry about that. I didn't know. Okay. So okay. So in case you have a list, and then you want to look for a value in the list without you knowing what is inside the list. You don't know whether Tolu is in the list or Ade is in the list. But you want to check all the values and see whether, okay, do I have Tolu on the list? Do I have Toki on the list or what? What will you do? You have a list. Let's imagine you don't know what's the content of the list. You don't know. But you want to check every content and see whether they are on the list or not. What will you do? Okay. Okay. So let's say we have a mail report check. So this is what we want to check for. So for a list, for us to be able to see, check all the variables in the list, we have to look through it. So we have to say for name in my list. For name in my list, then we compare if name equals to what? Check. You can put it in the if statement. Say if name equals to check, then we do something. Else you can print this one should be so like that. Else you can print not what for for for. So this will work. Someone in the comment in the chat also says we can do if check or if Tolu sorry, I'm not. Most of the time I'm teaching, I like standing and moving up and down. I'm not used to teaching on this. Okay, so we can do if Tolu in my list. And then we can do these two will work. But the reason why I'm not using this second method, is because this one we only check, it won't give me the index number that particular item is on my list. Listen. And there's something they call Pico Notation. Pico Notation. This is very important for every for anyone who may want to call him or herself a software engineer. So I'll be telling you a lot of things that you should write down and then go on to check by yourself because we can't cover everything within a short period. So big O notation, it will tell you how fast or how slow, it will tell you how fast or how slow your code will be. So for list, list has a, it's always written in this format. List has, for list, if you want to search for a variable, whether a variable is inside the list or not, it has a lookup time of n, where n is the, n is equals to the length of the list. You understand? N is equals to the length of the list. So for you to search if a particular variable is inside a list or not, you have to look through it in order to get the index of that list. And maybe okay, let's say for example, you want to search if a value is inside a list or not, and get the index of the list and then change that value. Do you understand? Let's say for example, we have a list, okay? Let's say we have a list that is all filled with rows, 0, 0, 0, 0, 0, 0. Okay, so normally this list should be filled with zeros, but there is a 1 in the middle. So you want to check if there is 1 in the list, and if there is 1 in the list, you should change it to 0. So for you to do this in a list, you have to look through. There is no other way. You can do if 1 is in my list, you can do this other one, but you won't be able to change it because you won't know the index that particular value is. You understand? So it will just tell you that there is 1 in the list. But for you to be able to change it, you have to look through. That's searching. You have to search for it. And when you search for it, then you can correct it. Are we cool with that? But for dictionary has that's for search. We're searching for a variable, yeah? So dictionary has a lookup, of a constant time. That's 1. So for dictionary, it has what we call archive. Maybe I'm even going back. So just know that for dictionary, if you want to search for anything, it's constant lookup time. You just give it that name, it will look for it immediately because it has stored it in its memory in a sense. That's why they used to tell you that a key in a dictionary is what? Unique. Each individual key in a dictionary is unique. A dictionary cannot have the same 2 types of key. You have to know that. So once you give it the name of the key, it knows where to go and it knows what to do. So you don't have to look through to search for it. Do you understand? Are we cool? Okay, so let me just give you an example. Let's say you have a, okay, let's say you have my dictionary. Okay. And then let's say our keys are, okay, the names are they. All right. You see. This is your, let's see, we have fire one, and then put baby yet. Okay. let's say Mayowa is now going up now, and then you want to change the value of Mayowa to a boy instead of baby. What you will do is, at first you ask yourself if Mayowa is in my what? Oh, sorry. Let's call this on my dictionary. So, if Mayowa is in my dictionary, if is in my dictionary, then what? Then just say my dictionary. Mayowa equals boy. Okay. So let me just create another stub here so we can run it and then you can see it. And so you know I'm not displaying magic here. And then when you call my dictionary now, you can see that it has changed. Can you see it? Can you see it? Let me break it down for you so everything becomes a bit easier. So before you can see that Mayowa was baby. So when we change it here, you can see that Mayowa is now a boy. But for a for loop, for you to be able to change anything, you have to look through it. And then once you get to that particular place, then you change it. You understand? So so you guys mentioned, let me check the whether there is any correction. Have any any issues? Okay. So for the data types, you guys mentioned list, strings, integers, and what again? Tuple. So there's another one called set. You can go and search for that one. And then we have float. We have decimals also. Okay. So then you guys are familiar with for loops now. At least we've played with for loop now. You've seen the if statement. What about the while loop? You guys, okay? So that's nice. Okay. So I want to do then we'll now move over to machine learning now, since I'm very confident with your Python skills in a sense. So welcome to machine learning. So can someone tell me, based on your understanding, when they say machine learning, what comes to your mind? Okay, can you just tell me your name and Musa? Okay.
Machine learning is a subset of AI that enables machine to improve experience.
Okay. It's a subset of AI that what?
Enables machines to improve experience.
Okay, so it enables machine to improve with experience. Okay. Okay. Can someone give me something else? Do you all agree with that? What about our ladies in the room? You want to give me the definition? Okay, what about people online? So what do you guys understand by machine learning? So there's no wrong or right answer. At least I've not taught you that, so you're just learning. Okay. So, yeah.
Okay, it's simply try to teach to make machines perform some tasks by themselves. After based on some experience.
Okay. At least from two of your definition, you know that they mentioned experience multiple times. So, machine learning is a subset of AI. AI is broad, quite broad. So, but machine learning is a subset of AI. And what machine learning does is try to get insights from data. And when I mean data, past experiences. It's trying to get, okay, what are the similarities in this data? What is the most notable factor that whenever that factor occurs, it will lead to this particular prediction. So machine learning is trying to get insight from data, get insight from past experience, so I can predict future occurrence. You understand? Okay. So you guys have been introduced to coding over times, and how machine learning is different from manually coding the solution, because most of what machine learning can do, you can basically write a program, a function for that same task to be done. You understand? Most of what machine learning can do, you can write a function or a syntax to perform that same function. Like now, before machine learning came to be, you see some of these phones, they were still able to detect human faces. You see, most of it that use all those old phones, then maybe Nokia, you see, by the time they want to take pictures, you just draw a rectangular box. And you draw a rectangular box on the face. Eh? I don't know maybe you guys, but you guys should know all those phones now that I'm talking about. So you just draw a rectangular box on the face, and it was not using anything machine learning then. It was pure basic algorithms that was written to detect human faces. So there's a way a human face will look like, and some software engineers were able to write an algorithm to detect those faces. If you go online, search them, they have unique names, and then they will detect the face and then draw a rectangular box on it. But now we can use machine learning for that. We can show the machine learning pictures of different people's faces, and then we tell the machine learning, okay, this is how your face look like, this is how your face look like, this is how your face look like, and just read different people's different types of faces. And then so when the machine learning model sees an example of a face in a picture, it can confidently draw a box around it. You understand? So how is machine learning different from coding in a sense? For coding, you write a function. A function will collect the form of data. It used to collect variables now. No, variables are data also. Okay, let me just define data. When I mean data is anything you can impute in the system that can be digitized. Any form of information that can be digitized can be a form of data. So let's say, for example, temperature, we can digitize it, right? We have some sensors that can take in temperature. Okay, someone says the ability of machine to learn to do things like human. Okay, yeah, that's quite that's the future people are aiming for. But for now, machines still can't do things like humans. Okay, so where was I? Okay, yeah, so we have sensors that can take the temperatures of this room, and then from that, once I can input it into my system, I can train a machine learning model that can predict the temperature for the next 24 hours based on the previous data that I have. So what I'm saying, I was giving you examples of data. So anything that can be digitized is a form of data. Your images, your pictures, they are data also. You can put them in the system, they can be digitized. Your what's it called again? Your videos can be digitized. So can someone give me an example of something that you think cannot be digitized? That you feel cannot be digitized? You guys have to think now. There are some stuffs in our personal life that cannot be digitized.
Emotion.
Emotion. Okay. Yeah. Emotion is still around the borderline of what we cannot digitize yet. There are a lot of ethnic questions about that because if you use some machine learning model that can predict or that can say the emotions of people, but there are still a lot of ethical questions around does machine learning, can it predict or can it predict the human emotion? There's still so I would allow emotion. So what does that mean? Okay, thought, human thought also. There is still a lot of machine learning models. If you go online, you see some machine learning models that some people are saying that can predict human thoughts using human brain waves. But it's still it's not something that the scientific community really acknowledge. So human thought also. So I need, okay, someone says sleep, breath of life, growing plant from soil, truth or lie. Okay, so anyway, there are some, about the truth or lie, there's a machine that they use for investigation. I mean, I can determine whether someone is lying or not based on the heart rate. So truth or lie will not matter in a sense. Okay, so there are quite some other things like that that has not that human beings have not been able to digitize in a sense because we don't know where to draw the boundary around it. Where is the high, where is the low, and there's no a major kind of sensors or a sensor that can sense it and then impute it in the system in a sense. Or okay, so going on to the difference between normal coding and what's called and machine learning. So for coding, you have your function that set the data and then perform a request. So for coding, we have what we give instructions. Okay, we can say rules because our function is a what? Is a set of rules. And then it takes in data and then it gives out what? It gives out results. Do you understand? That's what we do in coding. We create our functions. Function is a set of instructions. We give it data, and then it gives us our results. And gives us our output. So a function does not give out a list of instructions. There's no function that does that. It just gives you your output. Then your program cannot take that output and then pass it through a set of instructions again to do some stuff. You understand? But basically, this is how coding works. But for machine learning, ML, Can someone just give me an example of how ML works based on my explanation?
So,
Hmm?
takes that seven,
Okay. Okay. So it takes in data. So it takes in result. Result here is past experience and data. Data here is what we want it to predict. Because our function also takes in data. Data is what we want it to work on, like the current thing we want it to work on. Do you understand? You have to understand the difference between result and data. That result is past experience. So let me just put past experience. Past experience, and then it gives out instructions or predictions. Yeah. Predictions would be better. Okay. Do you have any questions so far? So let's go into our notebook. We can. Sure. I hope you can all see my screen. For those online, can you see the data science introduction to machine learning? Okay, yes. Thank you. So we can proceed. So yeah, we just want to introduce you to what machine learning is. So most people, when they say about machine learning, they think is one big one big AI or one big all those iRobot movies that you guys have watched, Terminator doing something at the back end that is very, very complex in a sense. So that's not what machine learning is. Or some people look at something like this, where they are just training it with a lot of data and complex algorithms and things like that. So all these are what they project for you movies. But machine learning at its core is quite a simple idea, a basic idea in a sense. So Benjio defined machine learning. He said machine learning research is the part of research on artificial intelligence, seeking to improve knowledge, seeking to provide knowledge to computer through data, observation, and interacting with the world. That acquired knowledge allows computer to correctly generalize the new set. So what this is saying is that we provide computers with previous knowledge, with past experience, with observation, and then because of those data that are seen, you can easily predict the future. And when you mean generalize well, is when you give it a kind of data that it has not seen before, it can say, okay, based on my past experience, based on what I've seen before, this is how it should go, this is what I should do, and things like that. So someone say is using algorithm to pass data, learn from it, and then make a determination or prediction from something in the world. So simply put, machine learning is a what mathematical algorithms, which end goal is to what learn from data and make predictions about similar instances in a new data point. What that means, I emphasize similar. If you train your machine learning algorithm on to predict the difference between a yam and an apple, that means you give it the pictures of a lot of yams and a picture of a lot of apples, and you say, okay, this is an apple, this is a yam, and then you show it, and then you train your machine learning model to the extent that it can effectively distinguish between a yam and an apple. Now, if you now show that machine learning model an orange, no matter how brilliant or how much time or money you trained or you spend on training that machine learning model, it cannot predict that this is an knowledge. So whatever models you are training, it can only predict like what it has seen, like similar data to what it has seen before. It cannot predict based on what it has not seen or what it has not been trained on. You understand? And the example is just like a baby. If a baby has been seeing a dog or a goat very well, let's say a dog. If a baby is used to a dog, then it sees a dog. If the baby sees a goat for the first time, the baby may call it a dog. Maybe just say dog. No, you are not that will say no, this is not a dog, this is a goat. Because that's the first time the baby is what seeing a goat. And that's just the same thing with the machine learning model. If it has been trained on images of dogs, if you showed it a goat, it will likely predict that image as a goat, as a dog. So you are the one that will now have to say, okay, no, this is not a dog, this is a goat. And then you have to train it on how a goat looks like. Okay, so just like we said, machine learning is a subset of artificial intelligence. Artificial intelligence in general is just imputing a form of intelligence into a machine, into a computer, a form of intelligence into a computer. It does not have to do with machine learning most of the time. Let's say, for example, you have a door outside, that as you are pushing the door opens. No, that's a form of intelligence, because the door can know when someone is approaching it, and then it will open up, and then you pass through, and then it closes again. Is that not a form of intelligence? But for that one, there is no need for machine learning on anything running at the background. All what you just need, you need a sensor. What's the name of the sensor? Arduino. No, Arduino is not a sensor. Arduino is a board. Motion sensor. You need a motion sensor. Maybe motion sensor, maybe two. Yeah, motion sensor or proximity sensor. Once you approach a particular meters close to the sensors get triggered. And once the sensor gets triggered, the door opens, you come in and you go. That's a form of intelligence. There are some applications also that if you are using them, they feel intuitive. They feel as if they know what you want to press, they know where you want to go and things like that. That's also a form of intelligence, you see. And all those things are done through UI, UX. There is no need for machine learning at the back end for that one. So artificial intelligence is broad. That's what I'm just trying to say. But there's a subset of artificial intelligence that is machine learning. And then that's where we'll be talking about. So machine learning requires using mathematical model, statistical model, and you having to feed those statistical models with previous data so that your model can be able to predict future outcomes. Any question? Okay, so sorry, don't worry, we'll soon get to the coding now. And then under machine learning, we have deep learning, which is a subset of ML. Some people consider it as a subset of ML, some don't. So it's using multi-layer neural network to make predictions. And deep learning is quite very useful when it comes to text data, images, videos. They are superb when it comes to all those areas. And when I mean text data, I'm talking about strings and the rest. But machine learning models are quite good when it comes to numerical data. Numerical data are those ones that appear in tabular forms. So if you see your Excel sheet also, so you are familiar with the Excel sheet, I think that's how most data occur. And that's the kind of data we'll be working with. We call them CSV files. comma, separated value, CSV, comma, separated value files, and all, so that this kind of data ML are also good with and things like that. So, okay, so I have to define some of these concepts going forward, and please take note of them because I'm mentioning them and then so you don't, so they don't catch you unaware. So data, we define data as any form of information that can be inputted into a computer, into a system, into a digital machine, makes sense? Into it. So any form of data like that, we can return our data and then we can work on GIS. Do anybody know what they call GIS here? Okay. Okay, so that's also a form of data also. So a lot of data that you can work with. Our world is filled with them, built on them, and then so that's that. Another one, we have features. So features are the data points or the part of your data that you can use in training your machine learning model, in training your classifier. So when I say classifier, your machine learning model also. That label is what you are trying to predict. So let's say, for example, now you have an image of a dog, and then somewhere you write, this is a dog. An image of a dog, and in a place you write, this is a dog. So which one is your feature? Okay, let me repeat myself. You have an image of a dog, and somewhere you write, this is a dog. You have two places like that. You write, this is a dog, one place. Right? You have an image of a dog. So which one is your feature? Which one is your label or your target? And so if you agree the image is your feature, can I say hands? Okay. If you agree both of them are your features, can I say hands? Okay. So if you don't know any, so if you don't agree on none, can I say hand? You don't just want to raise your hands. Let me see. Okay. So the image is our feature, is what we can train our machine learning on. This is a dog, is what we are trying to predict. That's what we are trying to predict. That, okay, this image, this is a dog. That's our target variable. And that's that. So example again, if you have an image of an X-ray, and then you want to predict whether the person has cancer or not. Let's say you are using an X-ray to predict whether someone has cancer or not, but I don't think that would be an effective use case in a sense. So the X-ray is your feature. The target variable is whether the person has cancer or not. Do you understand? Okay. Let's say, for example, again, you have an Excel sheet. Most Excel sheet online will want me to log in. So I wanted to show you something. So you have the Excel sheet where the first column, you have the type of house, maybe bungalow, flat. The next column, you have how many rooms they have. You have the size of the house. The last column, you have the price of the house. So if you are trying to predict the price of the house now, the column that has the price, that will be your target variable. The other ones will be your features. That the ones you train your model on. You understand? So I'm trying to give you a different type of example with different type of data types. Let's say example again, you have a tweet. You have a tweet. No, you have a Facebook post. Let's just say Facebook post. You have a Facebook post, and then you want to determine whether this Facebook post is negative, positive, or what's it called? or is neutral in a sense. And the reason why some people want to do that is people that have businesses, that have big businesses, and you want to look what are people saying about my brand online. You can use some key variables and then search online, search tweets, search Facebook posts, and see what are people saying about my brand. And then and when the data comes back, there are a lot of tweets, maybe 10,000, 100,000, 1 million. And the individual cannot sit down with all those ones and classify them for you. That's waste of time, waste of someone's resources. And you can just have a machine learning model that look at those tweets and say, okay, this Facebook post, is it a positive, negative, or is it neutral? And then from there, you can say, okay, 90% of comment online are positive. That means you are doing something right. And then maybe you can just sit down with the negative and maybe look through them, pick some data point and say, okay, what is this person complaining about? How can we adjust and things like that? Okay, do you have any questions? Okay, so someone is asking online, yeah, it says, imagine making a German Shepherd your pictures and making your label, this is a dog. What if you input other breed? What will be the result? Okay, so for dog lovers here, you know that dogs, there are different breeds of dogs. So you can also use the machine learning model that can do that. So instead of saying this is a dog, you can say you put the image, this is German Shepherd, this is the Chihuahua, this is the which other breed, Ascension, Babu, like that. And then your machine learning model, once it sees the image, you can say, okay, this is a Babu. And you can deploy that kind of thing in the veterinary shops once the dog comes in. Because most owners don't know the breed of the dog, especially this area of crossbreeding, and so different breeds that we mix together and things like that. So once it comes in, you can build the ML model that, okay, this is the breed of the dog and things like that. Okay, so someone is asking, is there an ML that can generalize all of them? And to generalize all of them, that means you have to have trained it on all of them. That means I have seen previous images on all of them. If it has not seen an image of a problem before, you cannot predict that this is a problem. Simple as that. No matter how smart your ML model is. That's how I've seen an image. So from this image, you can see your data, features, label, your algorithm, inference, that's the prediction, you have the output. Key elements of machine learning. Okay. So to make a machine learning model effective, you have to evaluate it, one, and also you have to optimize it. That is things you should know. And again, how you represent the knowledge, representation. That's what kind of models will you pick or will you use for it, and things like that. Or what kind of model should you use based on the data that you have. Evaluation is how well is my model doing, because it's not just that you train a model and say, okay, I'm done. You have to know how well is it doing. Is it predicting rightly or is it predicting wrongly? And let me tell you, the first time you train the machine learning model, you may not be doing what you want it to do. You may not be predicting up to what you want it to do. The amount of accuracy may be low, or the loss may be high, and things like that. And then you have to adjust. And then that's when optimization comes in. You have to optimize some of the parameters within your model so as to give you the best positive outcome. You understand? Okay. I should minimize.
Oh, okay, okay. Yeah, because I would like to keep the chat up. I think maybe someone has to be tracking the chat for me in case there's anything. Okay. So type of learning, any type of learning, I'm saying type of machine learning models that we have, they can be grouped into four types. There are other types, but just these four types you can help you. You have the supervised learning. For supervised learning, and supervised learning is good based on the target, the kind of target you are trying to predict. If the target is a discrete variable, and when I mean discrete is, that we have discrete continuous for those people that did maths, a form of maths in school. So discrete are you can count them, continuous, uncountable. So a form of discrete is whether it's a cancer or not, a breed of dog, and things like that. Continuous variable, the form is the price of the house. The price of the house can be anything. It can be 1 million, something, 50 something couple, 2 million. It can be continuous. Just one change in the number would make it a difference. So price of the house, uh, what other form do we have again? The price of the stock market, price of Bitcoin. You can use yeah, and something like that. So unsupervised, so supervised learning. So there's an output for supervised. It has an output. Supervised machine learning model has a form of output. That's a target variable. So once you say data that has a target variable, what you can predict, then you call it supervised learning model. Hmm? But that target variable has two types. They can be discrete or continuous, and then we'll talk about that one later. For unsupervised learning, that one does not have a target variable. Imagine, okay, imagine they give you a data set of what your customers buys whenever they come to your shop. What your customers buy whenever they come to your shop. It's true, you can say, okay, based on all what these customers have bought, we can predict when next the customer comes, we can predict what the customer will buy. That one is not. But the example I want to give is whether you are giving an example of all the customers that comes to your shops and buy something. And you cannot individually say, okay, this is customer A, this is customer B. They are just together. People come, they buy, and the data set you are giving is, okay, by this particular time, this person came here, buy bag of rice, buy this, person came here, buy this, buy this, buy this. With that, you can create a machine learning model that can cluster your customers into different sections based on what they come to your supermarket to buy. Some people will come to your supermarket and what they're only buying is junk food. If they want to buy rice or they want to buy beans or they want to buy food like that, they will go to local market. They don't want to patronize your market for that. There are some of your customers that whenever they come, they only come to buy baby products. And you should know this. You have to know this. Especially if you are running a big supermarket chain. What are people coming to my supermarket to buy? So your model can create a kind of clusters and say, okay, these people are only interested in baby products and baby oil. Why these people are only interested in beauty products? They only come to your supermarket to buy beautification products and the rest like that. So semi-supervised learning is one sweet one, interesting field. And what this is trying to do is, imagine you have a data set that is incomplete, and then you have, let's say, okay, you have images of dogs, and then you have few of them that have been labeled.
German Shepherd, Bravo, and the rest. But you have a lot of them that will not label. What you can do, you can sit down with them and start labeling them so you can train your machine learning model, which will take time. But semi-supervised is saying, okay, if you have few of them that will label, mix it up with the one that will not label, and then your machine learning model will be able to still train on those unlabeled data sets and then still be able to make predictions. That's right. And then reinforcement learning. This is trying to train the machine learning the model to learn based on consequences and reward. So if it does something good, you reward it. If it does something bad, if you predict wrongly, you give it a form of punishment. So it's an interesting field also. There are a lot of works on it online done by these people. I think it's OpenAI or something like that. OpenAI. No, it's not open. Anyway, DeepMind, go and search about them. DeepMind. We've done some work about reinforcement learning and things like that. So yeah, saying supervised learning is the most matured, most studied, and so the rest of them are places where people are trying to get new discoveries and things like that. The researchers, most researchers are trying to see how they can optimize in that area. So let's just run through. Let's see whether we can be able to actually go to a bit of coding because I can see people are a bit tired. Let me check the chart. Okay, not the chart is next now. So supervised learning. This image clearly tells us what supervised learning is about. So we give it an input raw data. You have an algorithm and process it based on an output. So input raw data must have a target. Please know that. Okay, so our supervised learning model also, I told you it can be divided into two. We have the classification and then we have the regression. So the classification is when the target variable, the output that we are predicting, when it is discrete, that means cancer or not, whether the patient is sick or not, whether you sold the house, whether you sold the house or you didn't sell the house. Those are two discrete variables. The breed of dogs, no matter how large the breed of dog is, it has a finite amount of numbers. So that's the classification. Whether someone is pregnant or not, whether the person has cancer or not. I've mentioned that. Okay, whether an email is a spam or not also is also another classification. Those two discrete variables. As long as the output of what your machine learning model will be giving out, you can count them. They are countable. Then you put them under classification. But if they are not countable, then regression, like price of petrol, price of house. Let me see one example. Okay, amount of rainfall down to you can classify it. The amount of it can differ, even if it differs by 1 centimeter. That's actually new something also. And the price of the house and things like that. So under classification, we'll be at least we'll be teaching you guys about logistic regression here. Decision trees, random forest. These are types of machine learning algorithms that are under classification. And this is an example of a linear regression. You can see that it's classifying these two into blue or yellow. So this one can be an example of people that have cancer. This one can be an example of people that didn't have cancer, things like that. So you can see it draws a straight line. So we have linear, we have non-linear. We don't have polynomial types of linear regression. But what we just teach you about is linear regression. Machine learning is broad, but just get the basic footsteps, know the basics, and then you build on it by yourself. There's no course online that can take you through the whole machine learning in a sense. They can introduce some concepts to you. Just have to go online, keep searching. Some of them will even add links that further clarifies or in case you want to study more and things like that. So it's a broad field, but don't worry. I'm sure once you guys, it's just a step at a time, and then over time you guys become gurus on it. So we have linear, we have non-linear, things like that. Also regression also. The reason why we are spending time here is so when we get to the coding part, you don't get confused with things. So types of regression, we have linear regression, and we have decision trees regression also. I don't have an image of that here. So unsupervised learning, that one has to do with clustering. So whenever you hear anything like clustering, know it's unsupervised. I know that what differentiates unsupervised with supervised is that unsupervised, there is no target variable. Your data set does not have a target variable that you want to predict. You just want to cluster them and see what are the similarities of this data and how do they differ from each other. That's what you are trying to achieve in unsupervised. But in supervised, you have a target variable, even though it can be continuous or discrete, it doesn't matter. As long as you know what you are predicting for, amount of rainfall, amount of sunshine, the prices of the house, whether the person has cancer or not, whether the person is sick or not, whether the house is fine or not, supervised. So types of unsupervised, you have clustering, you have association. So you can see an example of clustering here. You can see that there is a similarity between this data, these various data points. You can see that how they are clustered together. You can see how these ones are clustered together. So your machine learning model, once you see the data, you can say, okay, these particular data have a particular form of similarity. So let me cluster them here. This particular data has a particular form of similarities. Let me cluster them here also. And that's how K-means algorithm works. So when next they mention machine learning algorithm to you or machine learning model, just know that these are the process that will take place. You have your data, that's your input, and then you do some data pre-processing on it. Because every data that comes in from the wide, from the real world, are always dirty, messy. You have to clean them. You have to clean them. You have to, because some data sets will come in and they will have a lot of empty. You have a lot of empty cells, empty values, and then you have to, in a sense, pre-process it. You have to clean it, just like a factory. Whenever the raw material comes, you don't just use it like that. The raw material has to go through what they call pre-processing. Just know that whenever your data comes, you don't use it like that. You have to pre-process it. You have to adjust it to what you want to do. You have to refine it to a quality of what you want to use it for. And then you pass it through your machine learning model. That's where the learning occurs. Your machine learning learns on them. And then once it has performed a learning, and then you do your error analysis. You check, you evaluate your machine learning model. Is it good or not? What are some of the areas we can improve on? What are some of the areas is wrongly predicting outcomes? Then you can say, okay, this is the area is not getting whether someone is sick very well. Then maybe should I get more data? Should I change my machine, the kind of learning model that I'm using and things like that. And then at the outcome, you have your model, your evaluated model. So no, so the process is input. Your data comes in from the wild, you process it, you refine it, and then once you refine it to your taste, then you pass it through your machine learning, the learning algorithm that you picked. Once you've done that, you do error analysis. Based on your error analysis, you know whether to go and get more data or to do more pre-processing on your data, or to pick another learning algorithm, and based on that, and then the outcome is your model. The outcome is your model. So do you have any questions? Okay, someone is asking what is nominalization, what is dimension reduction? So baby steps, let's not go too deep. So nominalization is a form of data pre-processing. I will just give you that, but you can go online, search more about it. Dimension reduction also, let's start with baby steps first. Let's not go too deep. Someone is saying, does learning affect precision? Okay. I don't understand what the person means. But precision is a kind of evaluation. It's a form of evaluation. We have accuracy, we have precision, we have recall, we have mean square error, a lot of evaluations like that. So how it depends on the kind of evaluation metrics that you are optimizing for. That is the one you check your model against. And how to pick the evaluation metrics is mostly based on your own personal experience or what people are saying online. Because no matter what you want to build, somebody has at least done something a bit similar to that. So you can go online and say, okay, when the person wanted to build this, what kind of evaluation metrics did they use? What are the advantages of focusing on this one while negating this one and things like that. Because it will be difficult in a sense to optimize your machine learning model using multiple evaluation metrics. To be in a form of difficulty that you have to overcome. And I don't think I've seen any research paper that talks about ways of overcoming that. But you can just focus on two and optimize your machine learning model on it. And how to know the evaluation metrics to pick, determine on the use case. What do you want to use the model for? If you want to use it for making business decision, then you may want to optimize for precision instead of accuracy. And that's the reason why. And maybe when we get to the evaluation metrics, you'll see how they are being calculated and what are the strengths and weaknesses of each, and things like that. Okay.
Let's not see if any of the learning methods has higher precision or precision.
No. Any of the learning methods mostly determines, it depends on a lot of things. There are some learning methods that are very good with numerical data. There are some that are very good with pictures. There are some that are good that can handle missing values. In case your data has a lot of missing values, the learning method can optimize for that. There are some that are good based on what you want, but your learning method would, in a sense, not determine your precision or your accuracy. But there are some learning methods that gives higher accuracy. For those people that are familiar with, there is something called cargo. Cargo is a place where companies give out data, and then you can go there, people can compete, bringing out their own models, which one is better, which one is not, and things like that. So, but there are some machine learning algorithms that have been found that they give very high accuracy or very high precision and things like that. But they may not be good when it comes to generalizing well in the wild and things like that. But mostly it does not. And most of all these big companies, most of them just use linear regression because that's what they are familiar with, and that's what they know they can explain the outcome, how it makes it easier a decision and things like that. But your learning method, your learning algorithm does not, in a sense, determine how high or how low your precision or your accuracy. Do I have any questions? Hope you guys are not. You guys are looking, your eyes are looking a bit troubled. Are we together? Don't worry. I'm sure when most of you came, Python was looking a bit difficult, but now at least you can understand it too. But don't worry, as times goes on, you would. There are some of the lot of things I will say here that you will pick. It's maybe when you are watching or reading it again that you pick it, things like that. So just pick the one you can pick. And it's like that. Someone is asking for 5 minutes break. Don't worry, we have the content on YouTube. You can pause me on YouTube and continue. But I'll wait a bit. So do anybody have any questions on maybe on Python or machine learning before we continue? Maybe you need clarity on anything.
So,
Okay.
aside from Python, is there any other software that can be used for machine learning?
There are a lot of subjects that can be used for machine learning. We have Java can be used, JavaScript can be used, and things like that. But the reason why Python is a bit popular is because machine learning is still in this early stage of development. So most of the people that discover some things about machine learning are mostly researchers. And the programming language that researchers mostly use is Python. And again, Python has a very large community base. So a lot of people are updating, creating libraries to help make doing machine learning on Python easier. But almost all programming language can do a form of machine learning. If they cannot train, they can implement. Like now, if you want to implement a machine learning model on the web, I would prefer you use JavaScript for web-based application where you want to display it or where you want to use it. If it's web-based, then you use JavaScript. But if it's hardware-based in the form of autonomous vehicles, robotics, and the rest like that, then we'll say you should use maybe C++ or Java because they are quite fast. They're faster than Python. But if your machine learning model will be on the cloud-based, then you can use Python because Python is good for scripting and the rest like that. Okay. Someone is asking, I have access to the slide. I'm sure the people within the chat, our community members will answer you. I'm sure they should give you access to the form of the slide. Okay, someone said you should explain what string formatting is. Can you explain string formatting and the use of items? Okay, I don't understand what the person means by item, but string formatting, it's quite.
I think that's dictionary.
Okay, dictionaries, are they? Yeah, items are just the what's it called? There is keys, there is items. So if you want to get access, okay, let me start from the string formatting and then we'll move on. So for the string formatting, it's quite simple. You say you create a variable. Okay, let's create a variable name number and then put 5 here. Create another variable name boy and put a DA. And then if you want to format it, you want to add them together. For instance, let's say you want to create a string like this that says the boy Ade ate 5 apples. Okay, so in your program, the boy, the Ade, the name of the boy may changes over time based on maybe based on the user. So you want that to be editable, and the number of apples the person is eating may change also, and you want that to also be editable. What you can do, you can just say print, you put F, and then you can say the boy, hmm, you put the name of the variable that you want it to display. The boy Ade ate. So instead of boy, let me just change this one to why do you have a boy? And then when I put it, you can see we have the same. So let's imagine you have a list. The name is a list. You have Ade, you have Ayo, you have Uche, you have Musa, and then the number also. Number is a list, and then we have this 185, this 110, this one 30, this one 100. And then you want to print what everybody eats. You can do it for, you can say for name. They may not have taught you this, but don't be bothered. For name, comma, number. Okay, let's put S here so that this is a plural form. In zip, don't be bothered. Name, comma, number. So you use zip in case you want to loop through what's it called? Through multiple objects at the same time. So they'll be looping side by side. So when a day comes out, 5 also will come out. When tire comes out, 10 also will come out. Do you understand? And then we have a name number. And then when we run this, oh sorry, it should be names. You can see. So this is string formatting in a sense. So this is the most easiest way to do it. And this open and close bracket, you can do multiplications inside, you can do additions inside, things like that. So that's how to format your string, the easiest way possible. And when it comes to items, so if you don't want to, if you want to list all the items out instead of all the keys, you can, which dictionary? Okay, let's say my dictionary. Let's say my dictionary, and I say items. It will give me all the item. Okay, sorry, let me put it inside list. Okay, why is it saying image? Okay. Oh, sorry. I know the reason why. I think I should. Okay, yeah. Sorry about that. Okay. So items will give you the what's it called? The key and the value the same inside. So if you look through this, if you want to look through this now, you see for key, comma, value in my dot items. Then you print key values. So it will give you the same thing. Yeah, so you can see that you make errors that you correct. So it will give you the key and the value together. But if you want only the key, the items you change it to keys. And then you remove this your value. So you get only the keys. You understand? So yes. So any other question before we move on? So there are a lot of resources you can go online. I think just I will speak with what's the Funmi, and then I'll give you some YouTube links. You can go online to better develop your Python skills, and even some online resources you want to develop your machine learning skills and things like that. But just go online. Online is your friend. If you are facing an error with the code or with the challenge, Google it. One of the best skills you can learn is how to Google stuffs. Once you know how to Google them, you'll find there's nothing you're working on that someone has not faced. At least your stages. There's nothing you're working on that someone at your stage, at your level, have not encountered before, and then they have solved it. So there's no need for you to spend countless hours trying to solve those things also. So if someone is getting up present charity, maybe if you have something to say, maybe just type it. I don't know, maybe I give you access to speak. Okay, so we have like 20 minutes more, so let's see whether we can cover. I won't try as much as possible to watch this, but let's just. Okay, so the first question, mention the types of ML algorithms. So what are the types did I mention?
Four.
Okay, can you list them, please? Okay. Okay. Supervised, unsupervised, semi-supervised reinforcement. What differentiates the two major types? So the two major types are the supervised and unsupervised. These are the two major types. So one has the target, one does not have the target. Okay. So just a quick, what I'm making remember is one has the target. That means one is being supervised by a target, one does not have a target, so it's unsupervised. Target. Okay, someone is asking under so under which type of ML does the following task belong? Cancer detection is what? Supervised, abi? Customer segmentation, unsupervised. Will a web visitor click an ad? Supervised. Okay, so is that a click or not? Will an NG component fails? Supervised. Fraudulent transaction detection. Why do you think it's supervised? So this one is a bit so if you have a data set that tells you, okay, fraudulent transaction detection is not supervised because now you imagine, let's say you're an engineer and then they tell you build a machine learning model that can detect whether a transaction that a customer makes is fraudulent or not. How will you go about it? Eh? Okay, let's start. You get those the transaction look fraudulent or fraudulent. Like transaction is you buy, okay, let's say the person buys buy clothes on Jumia, that's a transaction. Person send money to someone, that's a transaction. So okay, let's say I now give you a data set of okay, someone buy clothes on Jumia, fraudulent transaction. Someone like the basic stuff too can be fraudulent transaction. So it may not work. Okay. The enforcement in what sense? Tell me how you implement that. You are trying to hide on that. It may work, but your explanation is not in depth enough. Let's just stick with it. Huh? What about? Eh? But how you cluster it?
So bring transaction as similar to the person. And the one that must based on no, it's not supervised.
Okay, so this is if you're a machine learning engineer and then they tell you, how in a sense, how will you structure your data?
You can decide that some are fraudulent. Then the targets kind of
like now, how will you know? The issue is how will you know if a transaction is fraudulent? If you can get that, you know the how will you know? You don't know the person before. You only have his past previous data of what he has bought. How will you know this particular transaction that was made was fraudulent and it was not the person that made it?
Can we use the past thing that the person has bought? The thing the person has bought in the past.
And that's what you are using.
Okay, so if you know the thing that the person has bought and somebody is buying something that is different from what the person has bought in the past, I think they use that.
Okay, you are trying to get it, but you don't. It's segmentation. You know what the person has bought or what the person is likely to buy. So you segment that customer around that place. This is what the person is likely to buy. The person goes on Jumia regularly. He buys online regularly. So this is what the person is likely to buy. This is the site the person is likely to visit. This is the area where the person lives. and these are the things the person is likely to buy. Now, when you see a transaction that is not similar to what the person does before, then you flag it as fraudulent. Now, imagine, I'm trying to look for an example. Okay. Imagine, you know that, okay, this person eats at Mama Put, and does not do anything with his card online before. He has not bought anything online before. So then you saw a transaction online, NigerBet. Okay. Your model should flag it. It may be the person, but you should just flag it because it's unique. That's not what the person has done before. And if you know that somebody does not bet, and then you see the person's card being used to bet online, you should flag it. The person may now call that this transaction is not going through. Okay, please confirm. And if you see that this person has not transferred any money beyond 100,000 in a month, and then at once you see a transaction of 1.2 million, your model should flag it. It does not follow the person's pattern. That's too high. So that's how fraudulent transaction. So it's segmentation.
So the amount we are sending for like a month, is that not target?
Is that not?
The target.
No, it's not a target because you can box it in a sense. So you can see if you say it's a target, then your model will only depend on the amount the person is sending. Now, if I'm a fraudster and then I'm smart, and then I send maybe 10,000 instead of just billing this one, I send you 10,000 like that. Your machine learning model may not detect it. Maybe I buy something online, 10,000. It will not flag it. So it has to be based on the best prediction you can use, based on that person's unique lifestyle. So you segment that person based on his unique lifestyle. And there's a high probability that if a fraudster wants to buy something, he may not spend it on that person's unique lifestyle. He may want to spend it outside. That's fraudulent transaction.
Sorry,
So unsupervised segmentation, unsupervised. Segmentation, unsupervised. So email spam detection, supervised, whether they are spam or not. What about loan prediction? Loan supervised, loan prediction, supervised. Okay. So it can be either the regression or classification. If it's regression, you would say, okay, if it's classification, it will either your model will say, okay, should we borrow this person money or not? So if it's regression, then your model will say, okay, how much should we borrow this person that we know that this person can pay back? And so for those people that use Crowdy Wise, so what they do is, since Crowdy Wise, no matter who you are, they will give you money. But the ML model is how much should we give out to this person? The person can pay back.
I have a question on that.
Okay.
What if we build the model and luckily the trust has not to know the lifestyle of the person and just exactly what the person does?
And that means there is no use case that is 100% guaranteed. There is no use case that is 100% guaranteed. No use case. No matter how secure whatever you have is, if the person have your password, the person can log it. No matter how secure Gmail is, once the person has your password, the person can log it. And especially if the person is not finishing up and logging using China server or something like that. Because once the model determines, okay, the location is too far, based on where the person logged in recently, the location is just too far, then it may ask you to provide further identification or authentication. But if the fraudster can also provide those further identification, the person will still be able to log into your Gmail.
So how do you now draw the line? What's the threshold that, okay, when this happens?
So it depends on the internal process within the organization. Okay. How many fraudulent detection do you want? Because the more you build models or processes to counter this fraudulent detection, the more you create a kind of restriction also on your customers. Because there are sometimes your customer wants to live large and your algorithm will flag it like that. So the ease of use will also suffer in a sense. So you have to know, what are you giving up? What are you getting? What are you willing to give up? If you are building a model based on, if you are building your business model based on our ATM is very secure, just know that there will be a lot of restrictions on how to use the ATM and some of the authentication. Maybe they will ask for two-step verification before you withdraw. It will send you OTP on your code on your phone. That's what you type in inside your ATM. So there'll be a lot of restrictions. So it doesn't depend on business use case. You cannot build outside the business use case, and every engineer should. You guys should know that. Whatever you are building, always have the business aspect of it in mind. Okay, this one may be. So what are the 5 basic steps used to perform machine learning tasks? Okay, I showed you the image. Data, what again? Reprocessing, train it, what again? Okay. The data, that's the input, preprocessing. After preprocessing, you pick a learning model, that's learning. After that, you do evaluation, and every evaluation, you have a model prediction. Okay, we have just 10 minutes more, so I want to watch, but just for our next class, you can look into NumPy and pandas. So you guys type it down, NumPy, NUMPY, and pandas, and just go on your Jupyter notebook and do import NumPy as NP. So I'm sure they've taught you the import NumPy as something, right? How is being used, are they? Okay. So import NumPy as NP and just try to run it to make sure it's working. And also import pandas and PD. Let's try and make sure it's on. Go online, watch a lot of YouTube videos on NumPy, how it's being used, pandas, how they are being used, and try as much as possible to experiment and work with them. And I'm sure, Fumi, I'm sure by next class they'll provide you a form of data set that you guys can use it like those. We'll be running this NumPy and pandas with data sets, and it's important that you have one that you can load with it. So whether in the WhatsApp group, they'll provide you a data set that will be used in class. So that's that. So if I'll be the one taking you next class, maybe for those people that comes early, I would maybe just create like a form of exercise. Once you come, I've seen it on the board, and then you guys can play with that, and then before we start, we'll do a solution, and then we'll continue. So, any question?
before we call it a day. Okay, someone is asking for my name. My name is Leke, baby Leke. That's my name. So any other question? Okay. So if there's none, I'll be calling on my colleague, Funminiyi. Fumi will take you through what you guys are meant to do. And I know you guys have like a weekly assignment or something. Is there assignment? I'll call it. Okay, so thank you guys. See you next class.
Thank you.
Thank you. All right. So we'll stop here for today and we'll continue from here. Yeah, so we'll stop here for today and continue from here next class. All right, so enjoy the rest of your week and we'll see you next class.